just for N size. And if you're interested in learning more, here's what we have done at U of T. This is a very mature, like complicated topic that professors, PhD students, postdocs work on. But what if an undergraduate wants to work on? What if a first and second year wants to work on? Right? And for that, we have made a conference that is accessible to first and second years, and that's called QSite.
Yeah.
My apologies. And which you can see on the left side of the screen, QSite. You can read through all of those tags that we have available on the conference. It's coming soon, September 29th. Registrations are open. We have hackathon on Saturday night for you to learn how programming and actually run algorithms on real-time hardware that IBM offers. This is meant for undergraduates and made by undergraduates. So make sure to check out more information at qsitecons.ca or our Instagram, qsite.conference, or qsite.com. The second thing is called QLearn, which is, I would recommend taking a photo of this because it will be fun. QLearn is the other activity. It's a lecture series provided by upper-year undergraduates in giving a more kind of lecture style approach to learning this. Again, it's not a course, it's not for GPA, we're not going to keep going this where you don't show up. It's just a place for you to come and ask questions to upper years who are researching this field and learn about that through a series of organized lectures. So I lead the fun hardware lectures, my friend leads the fun algorithm lectures. He's a on-site PhD course. You can't say PhD course, but we get the point. In the hardware, you'll learn about semiconductors, superconductors, trapped ions, and split constants. You don't know what that means, that's the entire purpose of those, right? And in the algorithms, you will learn about what to run on these quantum computers and actually do that through some labs that we can. So my contact information is there. If you have any more questions, you can reach out to me at any time. Today, I'm able to Discord is there, and the email is also there. There'll be 1 hour per week, no commitment. But if you're interested in learning about this, as productive engineers, you should be kind of, knowledgeable about the emerging fields, even if they are not related to your interests, but they might impact your interests. That doesn't have to be key. Not everyone's maybe interested in that data, everybody's impacting it, right? So that's my little 5 minutes. I hope I didn't go too much over, and thank you very much.
All right. Thanks very much. All right, thanks to Vivek. So you can go to the lectures. So we'll also touch a little bit about kind of physical computing and computing with physical devices. Actually, today a little bit, and then later on in the semester. It's not the focus of the course, but we'll mention it a little bit. So okay, so today I want to finish up talking. This is way too loud, isn't it? So today what we'll do is we'll finish up talking about literals. We'll talk a little bit about different types of objects in Python. So we already saw kind of numerical, we saw text, stuff like that. So we'll do a little bit more of that. And then we'll go to functions and how to pass information to and from functions. If you haven't heard about functions yet in the context of programming, well, you will. So the first thing I want to talk about today is numerical literals. So if you remember a string literal, oh, and by the way, there is a pop quiz, but it's not graded, so this is just for practice. In fact, sorry, let's do the quiz now, since I put so much effort into it. So this is just for practice. It's not graded. It's just to see that we're all on the same page and we can do it. So what I'm going to do is I'm going to publish the quiz now. I think it would be available. So here, the availability is until 4/24. It's about right. So I'm going to publish it. So please, so I'll extend it just so that we're not pressed for time too much. So please go on Quirkus. The quiz is about to appear, and then I'll display the quiz on the screen as well. It's 2 multiple choice questions, and it's not for it's not for grades, except like you'll see how it goes, and next week it might be for grades. Are people seeing the quiz on Quirkus? Yes? No? Okay. Yeah. So go to Quirkus, go to the board, go to quiz, and get it for me. All right, who is not done yet? Oh, I put the question 3 at the end? Okay, sure. I just thought that I thought it wasn't on Quirkus, and then I decided not to do question 3. Do question 3, please. Yeah. I hear someone saying the right answer for a practice quiz, it's okay. But in general, yeah, so question 1 is here. Okay. Not for grades.
Question 1?
It's an error. I shouldn't. Yeah. Okay. All right. Okay, we're back. We're back. Apparently I messed up 2 things. So question 1 didn't have a correct answer, and 2, I thought question 3 was not included. So okay. All right, everyone. Hello. quiet down, please. So question 1 contained an error. Unfortunately, good thing it wasn't for marks. As was pointed out, it does run, it just doesn't print anything, and that wasn't one of the options. Sorry about that, we'll fix it. As far as question 2, how many slashes are printed? Well, you could of course try it. So the answer is 1. And the reason it's 1 is that if you remember from Wednesday, 2 slashes means put a slash there, because a slash is a special thing. If a slash is followed by, for example, and that's a new line, it's not slash and then new line. So 2 slashes represent the character slash. So question 3 asks you which code fragment contains a syntax error. So you can kind of see, if you look at the color there, that Paizo seems confused, right? So double is blue and then quote becomes gray. So that kind of indicates that it thinks that quote is an identifier, a variable name. And the reason there is a syntax error is, well, kind of Python reads it as begin string and then end string, and then once the string is ended, quote is like some weird thing, and then there is another string, but you cannot have string variable named string. So that's why it's a syntax error. So I want to distinguish again between syntax errors, so errors that involve, sorry guys, quiet down please, nobody can hear anything. Guys, girls, so what I was saying is syntax means the rules about how you can combine different elements in the code, and you cannot say a string, so that double by itself in quotes is a valid string. It's just that you cannot then have this thing, which seems like a variable name. Now, conceptually, of course, what the person would probably mean if they wrote it is they meant for the quotes inside the quotation to just be characters, but you can't do it like that. You can either do single quotes or you can do slash double quote. Okay, so this is as opposed to something like name not defined, which would be something like this. So if you say if a is equal to 45 but a is not defined anywhere, then you cannot say whether a is equal to 45. It wasn't even defined. But that's not a syntax error. You can in principle say a is equal to 45. It's just that in that particular case you couldn't if a was not defined before. And of course just saying 45 is completely fine. You can put any value anywhere, anytime. So you can say 45, the value is 45. If you write 45 here, it would be 45. Basically, well, if the quiz was for real, I might be more careful about it and not put a question that doesn't make sense. But in general, that is how it's going to run. So, about every week, when I feel like it, there's going to be a quiz. So it's going to be 4 minutes. It's going to be 2 or 3 questions. I'm going to try to make the questions be reasonable because kind of in part, like, of course, like, it's such a large class, like, there's ways to, do whatever. So I'm not going to try to incentivize this. This is just a way to incentivize you to come to lecture, or to try to, I know you can have a group chat where someone from the chat is in the lecture and, like, messages everyone, oh, there is a quiz, I'm online. But at that point, you might as well come to lecture if you're willing to do something so complicated. So it's a way to incentivize that, and also a way to kind of help yourself be accountable in terms of progressing, because if you know that there might be a quiz, well, like, you might try to catch up. I'll honestly try to make the questions reasonable, and also it's the best 8 out of 12, so if you mess something up, it's kind of fine. You have a lot of chances to make up for that. So we'll see how it goes. So I now want to talk about numerical literals. So putting numbers into your program, which we've already done. So for example, here is 45. You could say something like x is equal to 45. And here what we did is we put in the number 45. So 45 here is written without a decimal point, and Python reads it as 45 is a whole number, it's an integer. You could say something like y is equal to 45.0. We'll do it in more detail later on in ESC180 when we learn about binary representation and stuff like that. But for now, it's enough to know that Python actually cares that x is a whole number, whereas y was initially written with 45.0, so that means that it's what's called a float. So, which is short for floating point number. Right? And the way you indicate to Python that it's a float is by either doing something like this, so including a decimal point, or you can write something in scientific notation. So you can say, for example, 2e10, like this, and if you write it in scientific notation, even if there is not a decimal point, it's still considered a float. So a float in scientific notation. So if you're not familiar, so AEB, well, that's a little bit unfortunate, but so we'll write it like this maybe, means A times 10 to the power of B. All right? So for example, Z here is 2 to the power, 2 times 10 to the power of 10. So this would be 2, and then you multiply it by 10 to the power of 10, so you add 10 zeros here. So if you count, there's 10. Make sense? So why does it matter? Well, it matters because integers and floats in Python actually have different properties. So for one thing, floats are stored using a limited number of digits. So A cannot have an arbitrary number of digits. The number of digits in A is fixed, and the number of digits in B is also fixed. So technically, Python stores this in binary, so it's not exactly like what I'm saying, but basically what you can do is you can use A is about 18, something like that, so is about 18 decimal digits. And then B is about 4 decimal digits. Right? So that means that that's what you can do. The best you can do is you can store 18 digits, and approximately, it's like not exact, but something like this. So you can store approximately 18 digits in A, and you can store approximately 4 digits in B. So that means that if you try to do something like this, well, that's too many digits. So Python will just say that's like, well, in this case, it decided that's like infinity. It's not able to store this number because it can only afford so many digits to represent the exponent. So similarly, there is a limit to how small a number you can store. So you can have a very small number, right? So like 1e to the negative 200 is like a very small number. But if you try here, that's just 0. And that's because, so it's like a little bit less than 4 digits. So at some point, it's not able to store 2000 as the exponent because it's too large. So it just approximates as a 0. So any float is stored, so we say, with limited precision. Also, there are limits on how close to 0 the number can be without becoming 0, and limits to how large the number can be. right? And that's just because you cannot have an exponent that's too negative or too positive. It has to be 4 digits and actually a little bit less. So you don't get to store minus 2000. Okay? And of course, kind of as you know, so just to review for people who don't know, so irrational numbers are numbers that can only be represented, well, that's one definition, with an infinite non-repeating sequence of digits. So that's like an approximate definition, but okay. So a famous irrational number. So in ancient Greece, it was known that the square root of 2 is not a rational number. So the way they didn't have decimal representation in Greece. It was very annoying actually, but they basically wrote numbers in text. It was horrible. But what they've shown is that the square root of 2 is not a ratio of any two integers. So that's where the name irrational comes from. So here, of course, I can say 2 to the power of negative of 0.5, and I have an approximation for square root of 2, but I only get about 18 decimal digits. So it's not going to be an exact thing. This is actually an approximation for what square root of 2 actually is. It so happens that square root of 2 you cannot hope to represent in a computer because it requires an infinite number of digits, and the computer can only has finite number. So it's not in principle even possible to represent square root of 2 in decimal notation. So one question that people sometimes ask here is, well, okay, all right, so couldn't I just get, so it seems like storing square root of 2 is a problem, so, but like I know square root of 2, specifically I can just say square root of 2, or I can say pi. There you are, it's stored in a computer right there, right? It says pi right there, pi is irrational, but if you just have the symbol for pi, that's fine. If you just write square root of 2, that's fine, so doesn't that solve the problem of not being able to store square root of 2? Because you just wrote it down. And the answer is, one, yes, you can do it to some extent, but it could slow the computation down if you have to keep track of, like you say, like x is square root of 2, and then you say y is pi times square root of 2. If you, the way you would sometimes do in physics, like in high school physics, they sometimes tell you, like, don't plug in numbers before, numbers before the final computation, because if you plug in numbers right away, then you write down approximations, and then you propagate whatever imprecisions you have in how you wrote down the numbers. So wait until the end, then you have a formula for the answer, and then plug things in. So if they don't tell you that, they should, right? So here it's kind of the same thing. You can't plug in square root of 2 because that takes an infinite number of digits. So you have to keep track through the entire computation of what was what, and that's slower. But sometimes it works. Sometimes you can do it. In principle, and this is kind of advanced stuff, but I'll just mention it. I'm not going to test you on what I'm about to say. But there is a bit of a conceptual problem, which is, yes, of course, you can represent some irrational numbers using symbols. So you can decide that pi is this guy, and you can decide the square root of 2 is this guy, but there is only a countable number, in fact, a finite number of symbols that you can store in a computer, right? So for some irrational numbers, you can decide, okay, pi has a name, square root of 2 has a name, I'll just put those names in the computer and I'll keep track of them by name. But the vast majority of irrational numbers you can't do it with because there's just too many. There is, so technically the term is there are uncountably many irrational numbers, and you only can ever hope to name a finite subset of them. So the vast majority of irrational numbers, there's no possibility, even in principle, of just naming every one of them like we named square root of 2 and pi. If you didn't understand or don't care about this, that's completely understandable. We're moving on. So integers in Python 3, unlike floats, are unlimited in size. So you can say x is something like this. Well, that's like not actually a lot, but just copy this and I'll multiply it by 2 every time, and that way it'll grow very fast. I think we need another one, just for fun. So I can say that x is equal this. So I'll comment all of this out, and that's going to be fine. This is now x. On the other hand, if I say, oh, actually I meant that x is a float, was it not enough? X is just got to be infinity. So as a float, it couldn't manage to store it because this is way more than the whatever 20-something digits that in decimal that we're allowed. So it'll just say that's infinity. Okay. So that's numerical types. So I want to go back for a second to the quadratic equation that we had last time. So this was something like this. So I'm just copying and pasting. And this is what we got here. Right? So in this case, like the equation was whatever, 2x squared minus 20x plus 1 equals 0. And we found the 2 roots. So R1 is that, and R2 is that. So now let's say, okay, let's check our work. So is it the case that if you plug it in, so this would be a times x R1 squared plus b times R1 plus c, is it actually 0? And the answer is no. Why is that? Well, because R1 and R2 are actually, if you solve for them exactly, there would be an expression with a square root in it. As the square root of anything is either irrational or it's an integer. In this case, it's clearly not an integer. So R1 is only stored in precisely. You only store so many digits of R1, and then the rest are just rounded off. Okay? So as a result, you plug R1 back into the equation, and you get about 3 times 10 to the negative 14, so not exactly 0. So this kind of suggests that this one, although algebraically it's correct, right? So if the discriminant is 0, what you need to do is you need to say there is 1 root. It's kind of questionable, because you compute this b squared minus 4ac, and then you compute it to exactly 0, but if at any point the values of a and b and c were not exactly precise, then it's not going to be 0, even if mathematically it's supposed to be 0, because of the finite precision issues, because everything is just stored to so many digits in terms of precision. So is it justified? Well, it depends on the situation, right? So if a and b and c are actual integers, then there is no problem. There's not going to be an issue with rounding off, as it happens specifically for the quadratic equation. So in that case, you're fine. If a and b and c you got from some kind of data measurement where you actually measured something, then there is already imprecision in how you measure things. You cannot measure anything to infinite precision anyway. Right? So that means that you have a problem even before you got to the issue of, oh, Python can store enough digits. Python can store lots of digits, usually more than you can measure. right? So if A and B and C come from actual measurements where you did something with a ruler or something, or you weighed something, probably the scale that you weighed the thing on, or the ruler, actually has fewer digits in terms of precision than what you can store in Python. So it's already imprecise. You wouldn't worry too much about the fact that in Python it's also imprecise. Less of an issue. But that already means that comparing discriminant to 0, if A and B and C were measurements, just makes no sense. Usually it just wouldn't be 0 anyway. So what to do? Well, depends on the question, right? So it might be that in your particular case, you care about the discriminant being close to 0, but not necessarily exactly 0. So you could try that. Or more usually, it could be that you would just say, if the quadratic equation is such that the coefficients A and B and C come from measurements, then it would be an extremely, extremely weird coincidence as if there had been exactly one root, because like everything isn't precise, why would you expect there would be a one root? So that would be usually the situation. So that's kind of like that. There's no clear solutions. You need to look at the specific problem. And we won't get into this in this course. Later on, you'll see that sometimes those issues do come up even without measurements, but that's for later, and not for first year. So, okay. So, a few more things just about converting things between types. You can, if you remember, do something like ABC plus XYZ, and that would be like this. So you just stick the strings together. What you cannot do is you cannot say ABC plus 42. That just makes no sense. You cannot add a string to an integer, because what you're going to do. What you can do, however, is you can convert an integer to a string and back. So you can say str42, and that would be 42 in quotes. So that means that ABC plus str42, okay, str42 is actually fine. So that would be just ABC and then 42, because str42 is just the string that consists of the digit 4 and the digit 2. So you can stick it together with ABC. That is fine. So similarly, str converts to a string. So similarly, you can say something like int 43, and that would be the number 43. So you can have like 4 plus 43, so that would be 47. And that's because this is now the number 43. What you cannot do, so that's fine. On the other hand, if you try 4 plus 43 like this, that is not fine, because this is, again, trying to add a number and a string. So in one example here, I wanted to stick 42 after ABC, so I converted 42 to a string. Here, I imagine that I have a string that happens to have the digits, converted it to a string, and now I can add it to 4. So you can also go between integers and floats. You can say float 3. Well, that's just 3.0, so Python knows now that it's a float. It's not super relevant. You can do something like int of 314, and what that would do is truncate. So that means that the fractional part is taken away. So that's not exactly the same as rounding down, because if you do int minus 3.15 or something, that would be minus 3. So it's not rounding, it's truncating. So one trick that you would sometimes see, people don't do that, well, people shouldn't do it anymore, they still do it, is if you want to actually round, so here, to be clear, int of x is going to be still 3. So this is 3 because you just truncate it. So what you can do is you can say int x plus 0.5, and if you think about it, that does rounding for positive numbers. Right? Because if it's like between 3.0 and 3.5, then plus 0.5 still keeps it 3 point something, so truncated, that's 3. So 3.0 to 3.5 rounds down, yeah.
Why is 3 negative 315?
Well, because it truncates. It's minus 3 actually, I just mistyped. Okay. So on the other hand, if x is between 3.5 and 4, then you add 0.5 and that becomes 4 point something. So int x plus 0.5 in that case would round up. So that's exactly what you want. You can of course just say round x, and that will do it without the plus 0.5 trick and without having to worry about, okay, like this works for positives, but actually it doesn't work for negatives. Right? So for negatives, you would have to do minus 0.5. Does that make sense? Questions? Okay, let me check what the Discord people are saying. Okay. Hello. Okay. Yeah, that's always fun. So like Discord people, if you misbehave, I'll have to keep you on the phone. So keep that in mind. Okay. All right, so that's rounding. So one more detail that's like not that interesting, but you cannot do something like int 3.14 because 3.14 is not actually an integer. So of course you cannot do int praxis or something. That makes no sense. So what you can do, however, so int 3 would work. So what you can do in principle is int round 3.14. And that's now fine. It's not fine. I need to float it first. So that is now fine because first you get the text 3.14 to be the actual number, and that's a float. Then you round the float, so now it's an integer. So, or it can be thought of as an integer, and then finally you could just convert it to int. But directly, that's obviously an error. All right. Okay. Okay. So the reason octopus is on my shortcuts is that I taught ECE 324 last term, and they were like, wait, is it? There was an octopus question. There was an octopus example rather in lecture, and people were like asking that they don't put the octopus on the exam, and I was taunting them, so that's why. Okay. Anyway, so that's that. So for the last 7 minutes, I want to start functions. So functions in Python are kind of, but not exactly like functions in math. So here's an example that is like math. So if you say, for example, square of x, and you write it like this, this is the same as just this kind of math thing, where you say square of x is equal to x squared. Now, in math, you don't usually name functions using more than one letter, but that's just a convention, right? So this is basically the same. There's going to be nuances, but basically what we're saying is, okay, def means here comes a function, square is the name of the function, then x is the dummy variable that you put into the function, and then this is whatever the function computes. Yes?
So the parameter is usually what we want to evaluate? Or like
Well, it depends. We'll have examples. So this is just what you're familiar with. So return. So whatever comes after the return, that's the thing that the function computes. So from now on, I'll be writing code that uses functions like this. So in a few weeks, or like a week and a half, I'll explain why. For now, it's just that from now on, what I'm going to do is over here are going to be the functions, and over here is going to be code that uses the functions. So for example, I can say print square, I don't know, what's a good number? 9. Okay, so if I run this, it's going to print 81, and that would be because I said that square it's just a name. I could name it anything, but I chose to name it something that makes sense, right? So square of 9, that's 9 squared. So if I print square of 9, that's going to be 81. Make sense? So in math, like in Python, you sometimes have functions of 2 variables. So for example, you can have something like this. So here I named the function add 2 numbers, and here I'm sending 2 values to it. So I'm sending A and then sending B, and then the function computes A plus B. So in math, that would be, well, A is already taken, something like this, right? And again, I can just say print add 2 numbers, whatever, 1, 3, comment this out, and that prints 4 because this computes 1 plus 3. Okay, so I don't know kind of how many of you have seen functions of more than 1 variable? Like most of you. So, okay. So that's like that. So we already actually have a function that we've used quite a lot, which is print, which is a little bit different. A function like, for example, round is just a function that's built into Python, right? So what round does is it's a function, you send it 3.14, and it says the value is 3. So you can, of course, send not just direct literals, you can also send variables. So I can say like x is equal to 5 and y is equal to 7, and then I can say square of y. So that's a little bit of an interesting example. So what's happening here? Well, square of y is going to be 49 because that's what square does. It squares the input. The input in this case is y, and the value of y is 7. So it doesn't matter that over here this guy is named x, because just like in math you can have like f of x is x squared, and also f of y is x, g of y is y squared. Well, g and f are the same, right? Because if you are consistent about it, it doesn't matter if you name the parameter, the value that you're sending, x or y. So it actually happens quite often. So in math, not so much, but in Python, it happens quite often that you have name clashes. So over here, x and y mean certain things. And then here what happens is I'm sending the y to be named temporarily x when I'm computing square of x. Okay, but the way to think about it is what a square does. Well, it squares things, so it'll square y. It doesn't matter that internally it's named x. So you can also do, so this would be 49. So you can also do something something mixed, right? So you can say like whatever x times y minus 5 or something like that. And that's completely fine. That turns out to be 65. All right, it's 5 o'clock. I will see you on Monday. Have a good weekend. Bye.
Well, I mean, that's it. Quotes and double quotes or single quote or triple quotes.
We've done it, right? So, yeah, so here, for example, you have something like this, right?
Yeah.
So that's completely fine.
It must be in quotation.
Well, if it's a, well, so something that's inside quotation marks is text. Something that's without quotation marks is, if it's numbers, then it's a number, an integer, or maybe a float. Right?
So what's the difference between a literal with a number and just a number?
So that's kind of this thing, right? So here, for example, you cannot do something like this because ABC is a string and 42 is a number, so you cannot add them together. But if 42 were a string, so if it were in quotes, that would be fine. So str plus 42 in quotes, that's fine.
It's just like changes the type of data.
Yes. Well, I mean, like changes, but not like it changes everything. It so happens that they correspond, but it's Python doesn't know about it.
Thank you very much.
Yeah.
I have a question about next week Monday's lecture.
Okay.
I have a scholarship dinner when the lecture
Okay.
is
Well,
running.
like the lecture is recorded, so
Oh, okay. I was
Yeah.
just wondering if there will be a quiz during it.
I'm not gonna say if there's gonna be a quiz. If you have, so like,
It's
if you
just
have an
really
excuse,
important to me
yeah.
because I can only receive
Yeah,
a check if I
yeah.
go to
I mean, if it's university related, it's fine. If there is a quiz, you can request kind of an excused absence.
Okay, cool. Thank you.
Yeah.
I actually have two questions. The first question is about the functions.
Okay.
There are some built-in functions, right? Like print itself is a function, right?
Yes.
So can we modify built-in functions?
Yeah.
So like can
Well, I
I change
mean,
print as
you can. It's kind of annoying, but you can. So in Python 3 you can, right? So you can say. So I mean, so it's not so much modify it as you can just say I want print to mean something else.
right?
So I can do something annoying like
Oh, you
this.
could print as an
so-
element in your new function.
No, not exactly. So, sorry. Yeah, they did actually. Okay. Well, that's super annoying. Okay. So I'll just do return, and then I can say print is equal to square if I want to, and from now on, print is going to be equal to square. So if I say print 9. Going to be 18. It's not exactly changing the built-in function. You can, in principle, change Python or something like this. This would be a little bit
Another
different.
question I had is because like a lot of this is just practicing, like you said
Yeah.
also in your lecture the first
Yeah.
day. So if I have to take notes about this, so like how am I gonna practice these also? Is there some problem?
I mean, so there's readings on here, right?
Okay.
So.
Because I want to practice like
This one is like still kind of introductory, so there's not like it's hard to figure out how to practice that. It's more so kind of after Monday there's going to be a lab, and that's going to open up a lot of practice. All right.
Yeah, Susan felt that it was too much last year, so
Yeah. Okay.
has the keyboard stuff because we went into functional basis and we.
like yours or somebody else?
Okay, thank you. So I'll keep it and I'll message the person. Yeah. Yeah. All right. See ya.
Yeah, the requirements functional
Like, I had a question just that the pendulum thing is not working. I don't know why. I'm getting this start back here.
Capture is not defined.
But it was working, but yesterday, but I'm not.
No, like in this file, it's really true that like you haven't said what capture is.
But which line is that, right?
Well, like it's like the first line one.
First line, right?
Like that's the beginning of the file, and capture really is
I have to,
undefined.
I have to write the copy paste the URL of the something, right?
Well, you need to import something or something. So like capture, like there's a lot of stuff there. Hey, Arya. So there's a lot of stuff there that's just not defined. So okay, I'll answer questions outside. I'll let Ben set up.
Don't you have a class or like you have to hold one?
Hey, I'll just answer questions outside. I'll just finish.